In 1 through 8, we're going to use mental math to complete each one of the 8 problems. I like to think of it in terms of exponential. And so when I take this and translate to exponential, the base remains at the bottom. So 5 would remain at the bottom. What's on the opposite side of the equal sign, and I'm going to write a question mark here, that's what we're trying to figure out, will become the exponent, and the number directly behind the base is the answer. So 5 to what power equals 25? The answer is 2. Let's look at number 2. I'm going to go 2 is the base, 2 to what exponent equals 16? Now, a misconception I often hear students make is 2 times what equals 16. And I often will see answers, of 8. Remember, we're being asked to take 2 times itself a specific number of times. So 2 times 2 times 2 times 2, 4 times equals 16. Let's go to 7. 7 raised to what power equals 7? And the answer is 1. 6 raised to what power equals 1? 6 raised to the 0 power equals 1. Down below, 9 raised to what power equals 3? 9 to what power equals 3? This starts to get a little more confusing. So what can I raise 9 to achieve 3? I know the square root of 9 is 3, and I know I can represent square root as 1 over 2. So 9 raised to 1/2 equals 3. We're going to use a similar concept here as we look at number 6. 3 raised to what power equals 1 over 27? Well, I always tell students when they first start with these type of problems, just to think of this. Go 3 raised to what power equals 27? Forget about it being on the bottom and it being at a different level as this initial number. Notice that they are at different levels. This is in the numerator and this value is in the denominator. But at this time, let's just think to ourselves, 3 raised to what power equals 27? The answer is 3. Now, the 27 then has to be moved to the bottom, and so it becomes a negative 3. The exponent becomes negative. We can go back and think about that. We know just 3 to the positive 3 is 27, and then to move it to the bottom, we would have to have a negative exponent. Let's look at number 7. 25 raised to the what power equals 1 over 5? Similar to number 6, I'm going to ask myself 25 to what exponent, raised to what exponent, just equals 5. And this goes back to problem number 5. I know if I take the square root of 25, I end up with 5. So I know I have 1/2. Now the 5 is not at the same level as a 25. Notice it does go to the bottom, making it a negative 1/2. A common question I get from students is, where does the negative sign go? Does it go on top with the 1, the bottom with the 2, or out front? As long as there's one negative sign, this is the correct answer. You could also represent it as a negative 0.5. Let's go on to the very last one. 3 raised to what power equals a negative 3? There's nothing we can raise 3 to end up with a negative number. We can end up with fractions, right? We could end up with 3 to the first, 3 to the second, 3 to the third, or 1 over 3 to the first, 1 over 3 squared, 1 over 3 to the third if we make it a negative. But there's no way to come up with a value here. So this isn't possible. We would say this is undefined. This value will never be negative. This value will never be negative. The base and the answer in logs will never be negative. Now that's not true for the number that's behind the equal sign, and we can see that in a few of our answers.